Hello, my dear students, and welcome to your online class. This is, of course, your teacher Cosme Rovalino, and before anything, I hope that everybody is doing really well together with your family. Today, we are going to talk about physical and chemical properties. This is something that we have mentioned already in the class, but we are going to give it a review with some cool graphics that you are going to enjoy, I hope. Okay, so first let's define our objective for today. The objective today is to investigate the physical properties of substances. Okay, and what are the key concepts? If you remember, it's very, very important to remember our key concepts. So let's break them down. First, the physical properties of a substance can be observed and measured without changing its composition. So that means that anything that you can observe with your senses and also measure, that is a physical property. Anything that you cannot observe with your senses is not a physical property, right? Then, these physical properties include odor, color, density, solubility, magnetism, boiling point and melting point, among others. We're going to see some of these physical properties today in more detail. The next key concept is that physical properties can be used to describe and identify substances. That is to say, the elements, right? So, for example, something that is colorless, odorless, and freezes at 0 degrees Celsius is probably water, because these are the physical properties of water. And now, when dealing with chemical properties, the substance, natural element, or a mixture, or a compound must undergo a change in the composition. Okay, so that's something that we are going to discuss later on. And the last key concept is that examples of chemical properties include flammability and the tendency to rust or to react with other substances. So these are the key concepts, and we are going to discuss them in more detail next. Okay, so the physical properties of a substance can be observed or measured without changing its composition. The moment that you change the composition of matter or a substance, then you're not talking about physical properties. These properties can be classified into two groups. Okay, the first group is the properties that depend on the amount of matter in the sample. For example, mass, weight, volume, density, and size. These properties depend on the amount of matter. But there is another group of physical properties that do not depend on the amount of matter, such as color, odor, luster, malleability, ductility, freezing and boiling points, hardness, and physical state. Okay, so no matter how much, for example, no matter how much gold you have, either a little bit or a lot of gold, it always has the same color, right? And let me show you a little graph here showing the physical properties. So something that you can see, you can hear, you can feel, you can touch, you can smell, and you can measure. Now, to help you with the two subgroups of the physical properties, I'm going to show you a chart, okay, where you can ask a few questions. Okay, so on the upper side of the chart it says properties of matter, right? So the first question is, are these properties determined without changing the identity of the substance? If the answer is no, then you are talking about chemical properties, right? And then there's another question, of course, that we are not going to concern ourselves with today. But on the right side of this chart, you have the answer yes. So if the answer is yes, when you don't change the properties of the substance, then you are talking about physical properties. But there is the last question, which is, does the properties depend on amount of substance, the amount of the substance to be analyzed? If the answer is no, then you are talking about intensive physical properties, which are color, melting point, boiling point, and density. But if the answer is yes, if it depends on the properties of the amount of substance, then you are talking about extensive physical properties, which are mass, volume, length, and shape. So remember, the density is always the same, no matter the amount of substance that you are dealing with. Okay, next. Many of these physical properties can help identify a substance. It can be an element or a compound. Mass and volume depend on the size of the sample, right? But the ratio, that means the proportion of mass and volume or density, relates directly to the identity of the substance. Okay, so that's what I was telling you. For example, gold has the same density, silver, you always have the same density, and water, you always have the density no matter how much water, no matter how much gold, and so on. The density of a substance is commonly compared to the density of water, which we already know that it's 1 gram per cubic centimeter. And mass is measured with a weighting scale. So I'm going to show you here the two properties of matter. The mass is with a weighting scale, and volume, you can see here, is the quantity of matter. Okay, so next, let's talk about the volume, which is the amount of space that an object occupies, and it can be measured with a ruler if the shape is regular, or with an more complicated method that is called water displacement, right? And so what do you do with this method? Well, you drop the object into water, and the water level rises. So let's talk about the formula to calculate density, right? You are probably familiar with this triangle where mass is on the upper side of the triangle, and density multiplied by volume is on the lower side of the triangle. So here density equals mass divided by the volume. But if you want to calculate the volume, you can divide the mass by the density. And again, if you want to calculate the mass of an object, you only have to multiply density times the volume. Okay, so that is the formula. Next, we are going to see two little experiments. On the first experiment, you can see that the bucket, well, the substance here weighs 4 newtons, right? And when you submerge that substance in water, you're going to see that the weight is only 1 newton, but it has displaced the equivalent of 3 newtons. So we're going to see that how that works, for example, on a little boat. On the second graph, you can see that the weight of the displaced water indicates the weight of a cargo of cargo the boat can support before it sinks, right? Okay, so look how the boat is floating, and when you push it down, the water is displaced. Okay, so that's the quantity of water. That quantity of water indicates the quantity of cargo that the ship can transport. And we're going to see that in the next graph. Okay, here you have the boat floating thanks to the buoyant force. If you remember, we have talked about this. So you have the gravity pushing the boat down and the buoyant force pushing up. Okay, so what is displacement? Well, it explains why objects float or sink, right? If you remember, the buoyancy is the upward force that a liquid exerts, right, on any object immersed in such liquid, right? So the red arrows pushing up represent buoyancy. If the mass of the object is greater than the mass of the water that it displaces, then the object sinks, it goes down, it cannot float. But on the contrary, if the mass of the object is less than the mass it displaces, then we say that the object has the ability to float. Okay, so this is the reason why a very heavy, a huge and heavy boat can float, because it displaces a greater mass of water than its own mass. Next, we are going to see the physical properties that can be observed only during chemical reaction, right? So, for example, the ability to burn, what we call a flammability, is a chemical property of many substances. And to observe this, you only have to light a match. And well, this process of burning, that is also called combustion, gives off energy, which we can use, but it also leaves ash. So we're going to see a little graph here of what flammability is all about. Several substances gives off several colors of flames, right? And next, we are going to see the process of rusting. We can see that we start in April. By May, you see some of the process, July, August, September, October, and November. Did you see? So this whole plate of iron rusts not quickly, but certainly steadily. Okay, so reactivity is a chemical property that refers to the tendency of matter to undergo chemical reactions. Is the not all kinds of matter can undergo chemical reactions. Okay, so that property is called reactivity. For example, when iron rusts, this metal that is color silver, between silver and gray, combines with oxygen to become iron oxide, then it weakens. It is no longer strong, right? And brittle. That means it breaks very easily, as you can imagine and as you can recall. So in order to observe the chemical properties of a substance, it is necessary to change the composition. If you don't change the composition, then you are not talking about chemical properties. Okay, guys. So today we have been discussing physical and chemical properties, and our objective has been met. Thank you very much for your attention today, and I will see you around. Take care.